Good morning guys and welcome to Mind Your Math. Two different questions, both of which I have taken from the previous year's question papers of the Indian Statistical Institute entrance examination. Both of them entrance examination for B.stat and B.math. Now both these questions look different, but then a person who is used to solving these kind of questions know that they are very easy, and both of them are based on the multiplication tables of counting numbers. Yes, that is all that you need to know in order to solve these two questions. So now let us start with the first question. The first question is, find the digit in the units place of the number that is resulting from this particular combination. 2 raised to 100 plus 5 raised to 100 plus 8 raised to 100. Okay. Now I told you that in order to do this particular problem, all you need to know are the multiplication tables of the counting numbers. Here you can see that I have written a table in which the number 2 is raised to various powers, and I have written the digit in the units place of the number resulting from raising the number 2 to its different powers. So 2 raised to 1 is a 2, 2 raised to 2 is a 4, 2 raised to 3 is a 8, 2 raised to 4 is a 16. So I have marked 16, 2 raised to 5 is a 32, I have marked 2, 2 raised to 6, 2 raised to 7, and it goes on. What can you observe from this? If you look at this particular table carefully, you can see that after this particular power of 2 raised to 4, whose units digit is 6, you can see that this pattern again repeats. 2, 4, 8, and if you take 2 raised to 8, it will end in 6, which means that after every power of 4, the units digit repeats. So from this particular table, you can see that when the power is raised to a number which is a multiple of 4, it will end in a 6. Okay, so after that, again the pattern repeats. 2 raised to 5 will end with a 2, 2 raised to 6 will end with a 4, 2 raised to 7 will end with a 8, 2 raised to 8 will end with a 6, because 2 raised to 8 is equal to 256. So if I have a power which is a multiple of 4, the units digit will be a 6. Now let us look at the condition where the power is not a multiple of 4 or the power is not completely divisible by 4. If that is the case, when we divide the power and if we are getting a remainder of 1, then the units digit of the result will be 2. The example is 2 raised to 5. 5 is not divisible by 4. It leaves a remainder of 1. When you look at the pattern, you can see that the number ends with a 2. If the power is a number that leaves a remainder of 2, the number ends with a 4. And if the number or the power is a number which leaves a remainder of 3, then the number ends with a 8. So I have written down the basic points when you have to find the digit in the units place when 2 is raised to any value. You need to check if the power is divisible by 4. If the power is divisible by 4, the units digit is a 6. If the power is not divisible by 4 and it leaves a remainder of 1, the units digit is a 2. 4 and 8 according to the conditions. Now you don't need to by heart this. Okay, the reason being, you just need to write the multiplication table of any number and check for the pattern, just like the way we did before. Now when you raise 2 raised to 5, you can see that the pattern repeats. Okay, it is not possible for you to by heart so many multiplication tables and learn so many patterns. The basic thing that you need to know is that why we are doing this and what is the underlying concept. Now let us move back to our question, which is 2 raised to 100. 2 raised to 100. 100 is divisible by 4 because 100 by 4 will give us 25. So I know that since the power is a number that is divisible by 4, the number or the units digit in the result of this particular number will end with a 6. So in this case, the units digit is a 6. Okay. In the case of 5, you know it is very easy. 5 raised to any power, the units digit will be a 5. So this is a units. This is not the entire number. Obviously, you know that This is only the units digit. The remaining number is here. We are concerned only with the last digit. Now 8 raised to 100. You can either check the multiplication table of 8 or you can write 8 as 2 raised to 3. This will give you 2 raised to 300. Now our task is to check whether 300 is divisible by 4. If it is not divisible by 4, what is the remainder? 300 is completely divisible by 4, giving us 75 as a quotient and no remainder or 0 as the remainder. So the units digit in this particular number is also a 6. Now whenever we are adding any numbers, we first start from the units digit. We first add the last digit. So 6 plus 6 is 12, 12 plus 5 is 17 and 1. When we are adding, the 1 goes as a carryover. So the last digit of this particular combination is a 7. We need to find the units digit in the number that is resulting from this particular sum. Now this is a brilliant sum. This is an extremely beautiful sum and a very simple sum as long as you know the meaning of factorial. Now let us see how we can solve this very easily. It's a very basic tip that I am going to give you. What is 1 factorial? It is 1. What is 2 factorial? It is 1 into 2. Now what is 3 factorial? Okay, so this is the basic meaning of the factorial. Now you know that what is 5 into 2? It's 10. Okay, now keep it in mind. What is 4 factorial? What is 5 factorial? 6 factorial will have all these numbers and one more 6 over here. Now forget about 1 factorial, 2 factorial, 3 factorial and 4 factorial. Check 5 factorial. What do you see? You see a combination of numbers multiplied together. If I am asking you to guess what would be the last digit, is it easy or not? It is very easy. The reason being, when you are multiplying 10 with any number, the last digit will always be a 0. Now, where is the 10 coming from? Whichever factorial you are taking after 4 factorial, that number will always end with a 0 because it always has 5 and a 2. And after 10 factorial, you definitely have a 10 also. Forget about that, you definitely have a 5 and a 2. So from 5 factorial downwards, we always have the units digit as a 0. Now we are bothered about only 4 numbers. 1 factorial, 2 factorial, 3 factorial and 4. Let us add them together and see what is the last digit.